Hello, everyone. Welcome to ITS 350. So today we are going to continue with our discussion. So I know we had a break on Tuesday, and today we are going to, I believe there's no homework due today. And instead today we're gonna actually work on a lab. So we started a topic last week, which was to look at block ciphers. And in particular, we started looking at the data encryption standard, or DES, if you remember. So we started looking at DES. And basically, we were going over the algorithm. So the idea at the end of the day, remember, this is not, let's say, a programming class, but at the same time, you know, the techniques that we're trying to understand related to encryption are basically software. So they're code, they're algorithms. Right? So, you know, cryptography is mainly software. Right? And so we're trying to understand the differences between the algorithms so you understand how it works. And then when you work for, you know, for a company and people start talking about, oh, we have this latest product on cryptography, you know, they're not just gonna, like, you know, wave their hands in the air and trick you, right? Because you understand how all of this works. So that's what we're going to continue today. So if I remember, I'm just doing a review. What I remember we did last week, Thursday, is we looked already at stream ciphers, and then we were basically, so we've looked at stream ciphers already. And you should be seeing my the whiteboard, by the way. So we've covered that. And then I believe we were in the data encryption standard DES. And also we were about to start the XOR lab. So that's really what we're going to start today. I'm just going to go over some of the ideas of this this code, which is the code that, you know, you can perform basically block ciphers. So block encryption. So we covered stream ciphers. And we basically talked about all of that, the pseudo-random keys. We've talked about all of that. Then we started looking at block ciphers. And we went over the main ideas of a block cipher, kind of the steps. So we talked about the round keys and the basic idea of a block cipher. In a block cipher, the main idea is that you map n bits. So don't forget that n bits get mapped. So you map n bits to n bits in some scheme. And that's really what we're trying to understand in these lectures now is, you know, the various schemes that you could use. So we talked a little bit about modes of operation. So I remember we talked about modes of operation, like we talked about CBC, right? And we went over the diagram, so I'm not going to do that again, but I know we've covered that. So it's really important to understand that, you know, the diagram. All right, and then we started talking specifically about block ciphers. So block ciphers, right? And in particular, then we started looking at DES, which stands for the data encryption standard. Okay. So we looked at that. We kind of looked at the history of these things. And then we basically said that the data encryption standard, you know, after following the idea of mapping n bits to n bits, it needs to figure out that scheme, right? So it's gonna do, it needs to figure out a scheme, and the basic idea is to build, a Feistel network. Right, a Feistel network. All right, and then we went over the Feistel network, and then I believe that's where we stopped. You had your quiz. All right, we had a quiz on this one. So we will go over the solution of that quiz on Tuesday, which was basically to do the inverse. Okay, so that was our stopping point that last week. And then from there, we will have to finish up the data encryption standard. All right, so because today is lab, what I want to do today is go over the code. So we're going to go over the code on today and just kind of get an idea of how that works. Okay. So that was the quiz there. All right. So what we're going to do today then is we're going to start up our we're going to start our VM. So we're going to go ahead and start the virtual machine and work on just some of the code. And then from here, we'll be able to build a simple encryption, block cipher algorithm.
Professor Calix, would you like for us to follow along as you do this, or just watch?
Well, I would recommend that you follow along. I would. As usual, I'll probably leave some parts of this as homework for you. Okay. So what I'm going to do is I'm going to give you the code that allows us to do the encryption. And then I'm not going to make you do the data encryption standard, but we're just going to see how that would work. Does that make sense?
Yes, it does. Thank you.
So just, start up your virtual machine. As I said, this is writing desk from scratch, if you want to call it that. Although, we're not going to get into all the details of it. All right, so let me go ahead and start the VM, and then I will share it. And the code is not really that long, but I really just have to give you some of the key aspects.
One more thing, Professor Calix, there's a question in the chat about the quiz.
What's the question?
He's asking when the quiz will be graded.
Maybe next week. So I'll go over the solution certainly next week. All right, so here is the VM. So let me share this with you guys. All right, so you should now be looking at my virtual machine. Okay. And I'm going to start a terminal. So are you guys seeing the VM?
Yeah.
I am.
Okay. All right. So then, just like we've been doing this semester, navigate to the desktop. Navigate to the desktop. And All right, so then navigate into the folder we've been using. All right, and then on here, we're going to create a new script. And let's just call this, it's really just the XOR operation in Python, so we really can just call it that. Oops. XOR.py. All right, so you can see the code. So I'm going to need a random number generator. So I'm just going to do from OS, which is the operating system, I'm going to import urandom. Okay. And then from there, I just need to figure out some of the logic, right, that I would do. So the goal is, probably the homework will be to take some text file or some input, a string that's long, break it into blocks, and perform probably just CBC, mode of operation. So the block cipher encryption, right? So that will be the idea, and that's really what I want you guys to figure out. Now I'll give you the code, most of it, but that's the general idea. So what we're gonna need for this, we're gonna need a key, we're going to need to encrypt, and we're gonna need to decrypt. So we need those two functions, right? And then we just need a main function where we perform the tasks. So let's sort of start there. And I'm not gonna do the block cipher part just yet. I'm just gonna start, kind of from scratch here. Just gonna say my message, right? And then, some string. This is a long string. So like I said, I've had students in the past that actually did the entire, the images that we did in the secret key lab, they actually did that one. So you guys can try to do that if you'd like, but pretty much just encrypting a long string would be fine here. So this could be a long string, okay, long string. So once you have that, then you can do, basically you're gonna need a key, right? The cipher key. So create a function, gen key, and what we're gonna say here is that we want the key to be of a specific length. Length will be something, right? So we need to specify that length of key, let's call it, right? Or maybe length of block. That could also be the case. All right, and then after that, if you want to print your key, you can try print string is to typecast it as a string, and then you can plug in the key in here. All right. Then after that, this is the very basic approach. We're going to generate the cipher text. And we're just going to say encrypt. Encrypt. And what do you encrypt? In this case, you're going to encrypt my message, comma, key. Right? And then remember, this is all pretty much the same approach we've taken. It's really inside that's going to change, where we're going to do the block cipher or symmetric key encryption. So here we're going to do now you can print the cipher text if you'd like. So you can do a print statement here, and you can say string cipher text. Okay. And then after that, oops, sorry. And then after that, if you want to decrypt, you're going to get back the plain message. right? And that's going to be Decrypt. Decrypt, okay? And what are we going to decrypt? We're going to decrypt cipher text, comma, key. All right, pretty standard approach. All right, so now the key question is, how are we going to define these encrypt or generate key, encrypt and decrypt functions? So the first one we're going to do is gen key. So I'm going to go over here. I'm going to define gen key. All right, and I need to define what's going to go in here. So basically, I'm going to define the length that I want for this. So maybe the length of, so for now, to keep it simple, I'm just going to say length of message. So I'm going to say length key. And remember, sometimes with these things, we have issues in the number of bytes that we have in a block. So maybe we need for it to be even and things like that. So we'll have to work it out. So now we do length of my message, right? And that allows us to define a length, right? And then now we have gen key over here, 1, 2, 3, 4. So now we can make a call to urandom. And urandom will take the length. So urandom length of key length of key, right? And now we have basically this. So we need to return. However, we're going to also convert this to a byte array, right? So that means that it's basically, we're going to convert it into binary. Okay, so that's the idea. We're going to convert this into binary by typing byte array. And that's really why I'm giving you this, so that you use this approach and you don't have to, kind of try to figure it out on your own. You can just use these functions. So this will give you the key. The other one will encrypt and decrypt. And really, all that's left is dealing with the logic of how to break the blocks and how to encrypt and decrypt. Remember that in the the CBC mode of operation, you take one block, get the cipher, use that for the next block, and so on. So you kind of have to repeat that. And that's what we are going to try to do. All right, so this should give us the key right here. And then now we are going to look at the encrypt function. So define encrypt. All right. And we're going to say plain text and also the key. Okay. 1, 2, 3, 4. All right. And then now we want to perform an encryption. And so we are going to use the caret symbol, which is this one. See there. And the caret symbol in Python is basically a bitwise XOR operator on integers. So this will do the job for us very, very well. All right, and so what we're going to do is we're going to have to use what is called a list comprehension in Python. So we're going to create a list. Right, and in here, we're going to do, for I in range So for I in range of the length of plain text, okay? And so now we are going to be able to iterate through all the bytes basically in that plain text. All right, so we're going to say then plain text I, right, to extract the index from it, or the value according to the index. And notice here we're using the caret, so we're taking that letter, if you will, in the first letter in the message, the second letter in the message, and we're going to XOR it with the first one of the key. And therefore, it's like basically what you've done by hand, only now we're doing it kind of in Python. So every 0 is being XORed by the 0. So every 0 of the key, or 1, every digit, I should say, of the key is being XORed by the digit of the message itself. All right. Let me supposed to be a zoom in and a zoom out here. No, I think it's actually in here. Yes, zoom out. Okay, that's better. All right, so now we can do so this value, let's call it this list. The letter also needs to be converted to ORD, so the number, ORD, right? So that is like the conversion of the letter to the integer in the ASCII table. And that really completes everything. So now we take the letter, each letter, run it through the ORD, get the value of the ASCII table, and take that value and XOR it with the key. And then that should give us the, I'm trying to get this, everything to fit in here. Okay, all right. And this is really the value that we want. So now, I'm just gonna have to do this for now. Okay, so I'm just gonna do that for now. All right, and so this is going to be then return. And the final thing is all of this will be converted into a byte array. Okay. Byte array. And that's basically the idea. Okay, so this is the operation for XORing the plain text. So really when you're doing this, you can just use the function built in as is. All right, so I'm gonna move this up. There. All right, the next function will be the decrypt. Decrypt will be the other step. And it's, as you might imagine, that's pretty similar to what we just did. We're going to take here the cipher text now. So we take the cipher text, comma, and the key as well. 1, 2, 3, 4, and we are basically going to do the same type of idea. We are going to take ciphertext and convert it into a string. So I'm going to typecast it as string. Cipher text. And then after that, I'm going to perform the decryption. So I'm going to do a list comprehension. I'm going to take for I in range, where this is going to be now len of ciphertext, same idea. Ciphertext. And what we're going to XOR this time will be the ciphertext. Oops. The ciphertext I caret ciphertext I and a key. I, and this will be all, or should all be, converted back from ORD to CHR. Okay, and hopefully that'll work. So we would just take the zeros and ones again, XOR them back, and then just typecast them back in the ASCII table back to characters. All right, so we're gonna see how this works out, but that should be everything if I'm not missing any details here.
Excuse me?
Yeah, go ahead. Yeah.
For the CHR, is the parentheses supposed to go around key I, or is it supposed to stop at ciphertext I?
Where?
The second line in Decrypt, is that where the parentheses is supposed to go, or after key I?
CHR? Yes.
Yeah.
Yeah, this is a list comprehension, and list comprehensions are one-liners for loops. So what that means is, you know, I know it's probably new, but it's just more handy. It's instead of writing for I in range, you know, what was it? You know, let's say 20, right? And so what you're doing now is you do 1, 2, 3, 4. 1, 2, 3, 4. And so now you say, you know, CHR, and then within it, you're going to take cipher text I caret key.
All right. Yeah, I was just asking because in the encrypt function, in your return statement, the parenthesis doesn't encompass key I, it only encompasses plain text. So I just wasn't sure if they needed to.
No, right. I see where you're asking that question. I'll elaborate in a second. It's a good observation. I agree. But so several things. So one thing is I'm missing the return here. Just turn. Now the other, I want to make this. You know, when I program, I hate things like this thing, so it's driving me crazy. But I don't want to make it smaller either. So anyway, the point is this for loop, right, which is the standard thing that we usually do in programming, can be made into a one-liner in Python using something called a list comprehension. And basically what you do is you take this part here and you move it kind of in front of the for loop. You see that?
Yeah.
Yeah, and so that's sort of what I'm doing with the list comprehensions here. I'm just doing that for convenience. And that's why then the CHR is only around this. So let me put it in another way. Let me go back to the whiteboard and kind of give you an idea of why that is. So if you think about it, when you have a plain text, right, you have, the cat sleeps, right? And we want to encrypt that. So what we were doing initially is we are iterating through these letters, right? And we are XORing them with a key. So key I, and then we just take that, let's say this was, S for string. So we were iterating through S, I, right? And then we did the ORD, correct?
Yeah.
Yeah, so that's what we did. And that was just so that we could make this into like numbers. And then we can XOR this with numbers. You know what I mean? That's what we were doing.
Gotcha.
Yeah, and the other one, this is the encrypt. And the decrypt, we were kind of doing something a little bit different, which is we were doing, we were taking the key again, right? Taking the key again, but now we are decrypting. So we take whatever's in the cipher, which remember the cipher is the combination of these two, right? The combination of those two, it's like that's the cipher thing, right? And so we need to take that cipher, let's say I, right? And we XOR it. Oops, I already wrote it. Maybe I should do that. All right, and so we do cipher I, right? And we XOR it with key. What does that do? It takes, by doing that, the equivalent is we're taking that away, correct?
Yeah.
And that gives us back basically this. So we need to go back to that. And so that is why after taking that out, we are doing CHR. Do you see that now?
Yeah, definitely crystal clear.
Okay, great, excellent. So that's really what's happening there. It's just, how you do it in. Okay, so that's basically the idea, as I said. So this code, today I'm just going to ask you guys to play with this a little bit. Start thinking about how to do, I want you to really, us, because it's a lab, right? I want you to just play with this, okay, and figure it out basically. But this is the idea. Unless I have any like errors, I'll double check that I didn't mistype anything. But hopefully the code would work, all right? We'll see that in a second. So now let me just save it so I don't lose it. All right, and then now another thing I want to do is I'm gonna open up the Python interpreter.
We can't see the terminal.
Oh, you can't see it.
Yeah, you're still on whiteboard.
I'm sorry. Let me switch over to. All right, so I'm now in the Python interpreter, and I just want to show you what the caret does, right? So if I do 0, 0, caret 0, right, that gives me a 0. If I give 1 caret, oops, 1 caret 1, what should it give me for an XOR?
0.
0, right? There we go. If I do 1 caret 0, gives me a 1, right? Just like it does an XOR. And if I do 0 caret 1, what should it give me?
A 1.
A 1, right? And so that's basically what happens there. You guys see that?
Yes.
Yeah.
And so that's really what's happening there. And so that's, that's the idea. And so that's, and that works also if you give it integer. So if you give it an integer, it's just going to convert it to binary, perform the operation, and it works the same. All right, so that's sort of the idea with XOR. Remember, the caret is a bitwise XOR operation, and I've given you the code. So now let's test it out, and if I have any errors, we'll work through them, and until we can figure this out. So that's that's sort of all we're doing today. Kind of a easy, at least not too many things. All right, so our script is called XOR. All right, so let me run it. See what happens. All right, so there's an error. For string and int. All right, let's take a look at it. Just gonna make this a little bit bigger or smaller, so I can see it better. Okay, so let's see. I have my message. This should all be correct. Generate the key. Print the key. Let's see if it gets that far. All right, so you can see here, it printed out the key. You can see the key there. I'm highlighting it. It's, it looks like that because it's bytes, right? So it's, when it gets printed out, it just grabs strange characters. And then the error, the error is happening in the decrypt function. So it didn't like the decrypt. Okay, so let's see the encrypt. Okay, so this is the encrypt function. Oh, so it's, why is it not, it's printing the key. Just gonna ask printing ciphertext. Print ciphertext. Let's see if that comes out. Just tracing the error. All right, ciphertext is there. All right, so that it printed the cipher. So you can see this is the cipher, which looks different from the key, right? So you can look at the key there, kind of looks like that. So definitely they're different, seems. All right, so now, decrypt ciphertext says return ciphertext.
Professor?
Yes. Yes.
In your function, when you're declaring your function, you don't have an underscore. Does that make a difference?
Where?
For cipher key, throughout the program, you have ciphertext with an underscore in it, and in that function that you just passed up, there's no underscore. The DEF decrypt.
Decrypt. Oh, I see. Yeah, but the issue is that decrypt only uses its own local function, or sorry, its own local ciphertext. And so here, even though we pass it a cipher underscore text from the outside, it gets assigned to this one. So that's a good observation, but that, here, they do have the same name. So let's see. I convert the ciphertext to string and call it ciphertext again. And then I do byte array here. All right, so the only issue is this function, it seems. Everything else did not break. so far. So let me, all right, let's see. That looks correct. For I in range,
It looks like it's some kind of data type thing because it says that they're not that you can't use string and int together for the operands.
yeah. Let's see. We get, so let's think about it. Ciphertext is, it's a type of byte. Well, let's comment out this one then. See what happens. Control F. The error is unsupported operand type as for caret, string and int. Key is probably an int type. All right, let's try it again. Oh, okay. So it did that. But now it ran. However, it did not decrypt, correct? So it's progress. So now let's take a look at the code here. Ciphertext, you print ciphertext. You can also print it without. Text. Oh, I didn't print plain message. Okay. Could it be that simple? Probably not. All right, so let's see, plain message. And then we would say print decrypted. So let's try it one more time.
Professor Calix, what was the statement underneath the print statement you just created? The print statement you just created was decrypted message. What was underneath that?
What do you mean? Where?
I see it. It's I was looking for print and then in the parentheses plain message.
Yeah, I'm printing the decrypted. So you can even say decrypted plain message, basically, and then just do that here. Decrypted. You see that?
Yes, I do. Thank you.
So I'm going to look at the message here. This is a long string on October 15, 2020, right? So we should get that back out. So let's try it. And there it is. So we get the key. I really need to label this a little bit better, but that should be the key. Ciphertext is here, right? Ciphertext. We're printing that twice, if you remember, because I'm printing it with and without the typecasting. And then the decrypted message. This is a long string on October 15th, 2020, and that's pretty much the original one. Does that make sense, guys?
Yeah.
So, okay, so what did I just give you? What did I just give you? So let's just think about that in terms of, I'm going to go back to the whiteboard. So you should be looking at the whiteboard now. So by hand, you know, when you guys did your exams and everything, I asked you to create a simple encryption algorithm. One of the problems, can't remember which one. And what I was saying is just take, you know, 0, 1, you know, 1, 1, 0, 1, whatever, and XOR it, right? And then you guys did, you know, you know, the XOR, we just did that, which is the caret. So that caret is this. And then what was this? 0, 1, 1, 1, 1, 0, 1, 1, correct? Is that correct? And that's the key, that's the plain, that's the cipher, right? And that's really all I just did in Python. This, nothing more than that. Would you agree?
Yeah.
Okay, that's all I did. However, as you guys know, ECB, which would be the next step from this, you know, it's not just that, right? There's actually a whole logic to it. And then after ECB would come DES, right? Which is, you know, it takes some of the ideas from here, from ECB, and it takes some of the ideas from the XOR. So you build on top of these primitives, right, in cryptography, and XOR in particular. So that's what I want you guys to do today as part of the lab. Is I just want us to work on this, and if you have questions, ask, right? But really, the goal is to implement ECB. So what does that mean? What do I mean by that? It means to do that graph, right? To do that, to do the graph. Now, I've already given you the hard part, which is the XOR operation. We know it encrypts and decrypts. So now you just have to do the other part. So let me remind you of what I mean by that. So if you think about it, what was CBC? CBC, right, we did that, is a mode of operation called a cipher blockchain. And how did it work? What did you have to do in CBC? Do you remember? Can anyone tell me?
You had to XOR the plain text with an initialization vector at the start, and then put the output of that into a cipher block in order to get your ciphertext, and then you would use the ciphertext to replace the initialization vector for all the subsequent blocks.
Exactly. Very, very well put. Exactly. And that's exactly what I want you to do in this lab. So this lab assignment is really just this one problem. I'm going to help you, but at the same time, I want you guys to try to do this. It's not as difficult as you might think. All right. So you have a plain text message, right? So first thing you need to do is you need to take a really long message, right? And you're going to break it into even blocks. And then you need to pad, right? The padding. So you need to do that. So you take the initialization vector. You already know how to XOR two blocks of the same length, right? So that's not a problem. So then, you know, you got the initialization vector, right? Vector. And, you know, let's just say that, of the same length, XOR those two. And then the output of that also needs to be XORed with what? With the key. All right, and that's going to give you your, oops, I should have just done. So this is going to be, let's call it Cipher 1, right? Cipher 1. If this is plain 1. Or no, actually, no, not like that. Might be confusing. Let's just say Cipher A, and then you XOR these two, right? And that, ooh, I should write this a little bit better. XOR these two, and that gives you Cipher, let's say, let's just call this one Cipher. And then now that Cipher becomes the input for the next block. So you're going to take plain, right? And you're going to XOR again, but this time with this block, right? That's going to be your initialization vector. And that's going to, you know, give you Cipher A, let's say, but for this one, right? So for this plain, so it's like plain 1, plain 2. So this would be 1A, 2A. All right, and then now that you get this, you take the key again. You're going to XOR And that's going to give you another cipher, right? And you just keep doing that until, you know, you reach the end. So say plain N, which probably needs to be padded. So you need to think about that a little bit. You're going to XOR with, oh, not that. You're going to XOR this like that. And then this is going to be cipher NA, right? You get from there. And then you have the key XOR, and that's going to give you another cipher. And then you'll have these, and then now you have your encrypted message, and then you just have to repeat the process for the decryption. So how would you approach this? What are some ideas? How would you approach this?
So definitely would need some form of loop, that's for sure.
Yeah. Exactly. So let's think about it. So for what? For block in list of blocks, right? So what does that mean? It means that over here you need to have list of blocks, right? And then that's going to be equal to what? Some kind of a function split string into blocks. Do you see that? And that will just give you a list of blocks of objects, right? And then you iterate through all the objects. You need to have your key, right? You need to have the initialization vector, right? You need to have the initialization vector, which are also random things. All right, so you get that, right? And then once you have that, what are you going to do? You're going to call the functions that you have already, right? Encrypt. And you give it block. And you give it key. Do you see that, guys? But you have to keep in mind that there's a double thing going on, right? There's two XOR operations. Because if you don't do the two operations, what do you end up with? What if you say, I can't do the two XOR operations. I can only do one. Is your algorithm secure?
Not really.
What do you end up with? What mode of operation?
That's pretty much ECB, isn't it?
Pretty much ECB. Very good. It's an excellent answer. Exactly. So although it's a little bit harder to do maybe in your mind, you have to do it because the other one is insecure or just less effective. And so you have to do that. So what I want you guys to do is think about this, okay? Start playing with this code, all right? And, you know, bring up questions if you have them. And, you know, we'll take it easy on this homework assignment, but I do want you to put in a little bit of work on it and try to solve as much of it as possible on your own, okay? Are there any questions?
Not at the moment.
All right, so start working on this. As I said, this lab is just one problem where you're going to implement, as I said, this mode of operation, which is called CBC, right? Yeah, this homework will probably be due next Thursday, but we'll see. We'll see. I want you, this is the one assignment where I really want you to get your hands dirty in the code. So I want to see how you do on it, okay? It'll really help you to figure out that it's actually not as difficult as it might seem. Okay, so start working on it, please. I'll be here for the rest of the time, and just ask questions if you have them. Okay, or otherwise just work on this lab. And if you have a question, just speak. It's easier for me. Okay. Yeah, I'll show the code again, I guess. Just show it. What do you want me to do with the code exactly? All right, so I'm going to go back to the code. So we got it to work, right? That's one thing. We ran it, and now I'm just going to, yeah. So again, I can go over the code again if you'd like. So you can see it's pretty straightforward. You need to have a string longer than the size of your blocks, okay? That's one thing. What's on XOR is actually what we're doing now. So actually, somebody reminded me that I have something on Brightspace about this, so let's go over there. All right, so you should be seeing Brightspace now. So if you're looking at Brightspace, you'll see that there's two modules, PyCrypto and XOR. We haven't started PyCrypto, so don't even worry about it. PyCrypto, it will be, PyCrypto is like the final practical exam of cybersecurity, or sorry, of encryption. So it's going to involve everything we've covered so far this semester, and you're going to work with a partner, and you're going to do all the authentication, integrity, all of that. So we haven't gotten to that one yet. Today we are only looking at XOR. As I said, I haven't created a homework assignment yet. I want to see how you guys do. Basically, I posted a little Word document, and it says, using the instructor provider XOR code, or use the instructor provider XOR code, which I just provided, to implement a scheme that allows you to encrypt and decrypt some data using symmetric encryption principles. Right? You can implement any scheme that you want, either one of the schemes discussed in the class or a new one that you design on your own. The key aspect is that you should generate several blocks from the input, and you should do several rounds of encoding. Implement the Python code and show your results. So basically what I'm saying, the simplest thing that you can do is ECB. Or sorry, ECB is wrong, CBC. Obviously, for those, you know, like I said, I had a student once who encrypted the images from the symmetric key encryption lab. You know, if you wanted to, you could implement the data encryption standard, right? You can do lots of things, but that is not required. The only thing that's required is to do CBC, what I just described, which is basically, what is it? This one, right? So this is really what I'm requiring you guys to do for your assignment. Make sense?
Yeah.
Are there any additional questions? Anything else you want me to do before you start? You want me to just leave it on the code?
Yes.
Yeah, sure.
Okay, so I'm going to put it on the code. As I said, please work through this. Yeah, code should work, and then just start thinking about how you would do the rest. All right, and try to figure it out. So let me switch over. All right, and here's the code as you can see. Okay, so you can see here, I can go over it really quickly again. Here's the message. The message needs to be longer than the block size, right? So the block size might be 10. The string could be 78 or, you know, something like that. Just make it somewhat long. Then I calculated the length of this. Then I gave you the function to generate the keys. You can view it. I gave you the function for encrypting a block and a key of equal size. All right. So that's the key thing to think about. Then you can print out the ciphertext. Then I gave you the function for decrypting the cipher and the key, and the logic was implemented there. You can see here, you just used a urandom function to generate the byte array key of a specific length. Make sure, for instance, your block and your key are the same size. That will solve a lot. You have the encrypt. So again, I explained this, how it works, right? So you just take the text, convert it to an integer, XOR that with the caret with the key. I explained what this is. The for loop is a list comprehension. And then you just convert everything into a byte array and return that. For the decrypt, it's kind of the same thing. But now you take, everything is digits here, bits, so you need to XOR them first. Then that kind of takes out the key, if you want to think of it that way. And then what's left is the ciphertext, which you can convert, or the integer, which you can convert back to string. And that's it. So play around with this. You have the rest of the lab. If you have any questions, let me know. I'll be here. All right, guys, we're going to stop here for today. Keep working on this problem. And then we'll talk about it on Tuesday just to see where you guys are with it. As I said, it's probably going to be due a week from today, but we will just see, okay? So I just want to see your progress with it and your ideas of how you're solving it. All right, and that's it. We're going to stop here for today, and I will see you guys next on Tuesday, where we will continue the whole Feistel network and pick up from there. All right, have a good weekend.
All right, thanks, you too.